welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze the NACA Airfoil 747A315, which is a 7-digit airfoil for its static structure analysis. We will start by double-clicking the static structural module. We'll first go to engineering data and double-click. Engineering data sources. We'll go to general materials and choose aluminum alloy as the material. Next, I'll go to project and update project. I'll go to geometry and right click and import the geometry of the airfoil. We'll double click on the geometry. This airfoil is of 3D type, which is what we are going to use. So I'll just go to the three parts that are existing here. Line body is suppressed. I'll also suppress the surface body. What we need is only the solid body. So let's close this now. We will now go to model and double click. We'll first go to geometry solid. I'll change the material to aluminum alloy. Next, I'll go to mesh and change the sizing to 0.01 meter and generate. You can make this mesh more finer. I'll leave it as it is because I'm using the student version. Next, I'll go to static structural and right click. Insert fixed support over here. Again, right click, insert rotational velocity on this body. I'll change vector to component. Along the z-axis, I'll give the rotational velocity as say 1000 rpm. Then I'll go to solution and right click. Insert deformation total. Insert strain equivalent. I'll insert stress equivalent. Then I'll insert fatigue tool. I'll give the mean stress theory as Goodman theory. Again, I'll right click here and insert life, damage and safety factor. Then I'll go to solution and solve. We'll first go to total deformation. I'll go to contours and select smooth contour, edges, no wireframe. So the maximum deformation is 0.00072 meter. I'll choose the unit as millimeter. So it's easier to now understand. 0.7 mm is the deformation. You can animate and check the result so that you know the direction of its deformation. Minimum deformation is 0 at this fixed end, and here it is going to be maximum. And in between you can see a range of values. Then we'll see the elastic strain. You can see here it is maximum. You can click on max min to know where the value is maximum and where it is minimum. Maximum value is 0.00038 and minimum is 7.39 and 10 raised to -9. So that gives you the strain value over the airfoil. Next, we'll see the equivalent stress. The highest value is 27.321 megapascal at this end, and in other ends it is varying, but most of it you can see is 0.000, which means it is approximately 0 stress in this zone. Then we go to fatigue tool. If you click on life, you can see the maximum life of this aerofoil is 1 into 10 raised to 8. Damage is shown as 10 because the design life is 1 into 10 raised to 9 cycles and your life is 1 into 10 raised to 8 cycles. So that is why the damage is shown here as 10. Safety factor is very interesting because you can see that most of the aerofoil portion is safe under this kind of rotational velocity. It is only this zone which will be affected and also this side. That then to the value is 10 because it is showing green color. If you want to see the variation, you can see it is in the range of 5 to 10. You can check. The probe is being moved over this part. You can see it is between 5 to 10. And this is showing minimum value which is 0. Your minimum is 0 and shown in red color. Maximum is 15 and shown in blue color. So that's how you analyze this aerofoil. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.